Today we are doing the problems on regression analysis. So we know that regression analysis y on x line and x on y line and the coefficients of regression lines also. So first we are writing the formulas. Y on x can be written as y minus y bar equal to r into sigma y by sigma x into x minus x bar. So this is for regression line y on x. Okay. See here in this coefficient of x can be we are taking as the regression coefficient y on x line, and this can be we are denoted by byx. Right. Next, the regression line x on y can be written as x minus x bar equal to r into sigma x by sigma y into minus y bar. Right. So x on y line, this one, and the coefficient of y is known as this can be represented by bxy, which is known as the regression coefficient x on y line. Right. So using these two formulas, now you are doing the problems on regression analysis. Taking of the given group of 10 members data they are given, and also they are giving the mean of x and y, variance of x and y, and also they are given summation x minus x bar into y minus y bar equal to 1220. So here we want to find out appropriate regression equation and use it to estimate the blood pressure of a man whose age is 45. So the blood pressure of at the man whose age is 45, here we want to find out. So that means here we are finding y on x line. In the regression line we are finding y on x. So after finding y on x line, then we have to substitute age x equal to, in that line we get so y of 45 value. That means so for 45 man age, what is the value of blood pressure we are finding using this one. So we are taking y on x regression line, and using the given data, first of all write down the given data. So they are taking number of observations are 10. So n can be taken as 10, and mean of x that can be represented by x bar equal to 53, and y mean is equal to 142. Mean is here represented by x bar and y bar. So y bar is equal to 142, and variance of x, variance can be represented by sigma x square is equal to 130. But in regression lines we want only sigma x. So this implies sigma x can be written as root over 130. So which is equal to 11.4017. Next, sigma y square is equal to 160. Sigma y square equal to 160, which implies sigma y is equal to root over 160. So root over 1 to 12.6491. Okay. So these are the given data, and also they are given summation x minus x bar into y minus y bar data, and which is equal to 1220. So now we want to find out, using the given data we have to find out regression line y on x. The y on x regression line can be written as y minus y bar is equal to r into sigma y by sigma x into x minus x bar. So we know all the values y bar, sigma x, sigma y, x bar, but we don't know the value of r. Here r is a representation for a correlation coefficient. So this r can be written as r is equal to covariance of xy by sigma x into sigma y. Again, covariance of xy can be written as 1 by n into summation x minus x bar into y minus y bar by sigma x value is equal to, we get 11.4017, and this is 12.6491. Right. So this is equal to, so already they are given summation x minus x bar into y minus y bar equal to 1220. So that can be written as 1220 into 1 by n, n is equal to 10 by 11.4017 12.6491. Here 1 0 0 will be cancelled. So now you are simplifying using our calculators. Get this value is equal to 0.8459. So this is the value of R. So now that value R we are substituting into the regression line y on x. So this implies y minus y bar. So y bar is there given 142 is equal to R into R values here we are getting 0.8459 into sigma y by sigma x. Sigma y is equal to here 12.6491 by and sigma x value is equal to 11.4017 into x minus x bar. So that x minus x bar equal to x minus x bar value equal to 53. Now we are simplifying this one, we get implies y minus 142 equal to, we are simplifying this one, we get, so this value is 0.9384 into x minus 53. Okay. So now this is also can be written as y is equal to this minus 142 we are taking into other side. So minus can be changed to plus 142 plus x into 0.9384 minus 53 into this one. We get 49.7376. Y is equal to 142 minus 49.7376, we get 92.2623 plus x into 0.9384. So this is y on x. So now we want to find out at the age of 45. That means in this equation substitute x equal to 45. So we get blood pressure of that age x equal to 45 value. Y at 45 is equal to 92.2623 plus here x is equal to 45. We are substituting 0.9384. So now we are simplifying this equal to 134.4903. So at the age of 45 the blood pressure is 134.4903 which is approximately equal to 134. Next we are doing the second problem. In a partially destroyed laboratory data, only the equations given the two lines of regressions y on x and x on y. So this is for y on x and this is for x on y. So using these two equations now we want to find out correlation x bar and y bar values, right? So for finding correlation and correlation coefficient first we are using the given two equation. So in the given two equations, the first equation we are taking 7x minus 16y plus 9 equal to 0. So this equation for y on x, second equation for x on y. So y on x means left hand side we are taking y and right hand side we are taking the constants and x values. So this can be rewrite as this implies 16y is equal to 7x plus 9. Right. So this implies y is equal to this 16 also we are taking into other side, we get 7 by 16 into x plus 9 by 16. So this implies this is also can be written as y is equal to 7 divided by 16 equal to 0.4375 into x plus and 9 by 16, 9 divided by 16 is equal to 0.5625. So this is the y on x line. In y on x line, the right hand side x coefficient is we are taking as the coefficient of y on x line. The coefficient of y on x line we are represented by byx, that is equal to 0.4375. So next we are considering the second equation, which is known as 5y minus 4x minus 3 equal to 0. So which is representation for second one, x on y line. X on y line means left hand side we are taking x term, the right hand side we are taking y and constant term. So this is also can be written as, this implies 4x is equal to 5y minus 3. So now this 4 is also we are taking into other side, we get x is equal to 5 by 4 y minus 3 by 4. Now you are simplifying this one, this implies x is equal to 5 by 4 equal to 1.25 into y minus 3 divided by 4 can be written as 0.75. So this is a x on y line. So the coefficient of y is known as we are represented by bxy. So this implies bxy can be written as 1.25. So here we want relation coefficient and x bar and y bar, right? So from the regression quotient, using the properties of regression, we know that the correlation quotient R can be written as root over byx into bxy. So we know byx, also bxy also we know. So now we are substituting here, we get root over 0.4375 into bxy is 1.25. So now we are calculating, this is using calculator. This value is equal to 0.7395. This value equal to 0.7395. So next we want to find out here x bar and y bar values are we want to find out here. See here, for finding this x bar and y bar for the given two equation, we are replacing x and y by x bar and y bar. Replace x and y by x bar and y bar. So we get the first equation is 7x bar minus 16y bar plus 9 equal to 0 and minus 4x bar plus 5y bar minus 3 equal to 0. So let it be, this is equation 1 and this is equation 2. Now we are solving equation 1 and equation 2. This implies x bar equal to, so directly using your calculator you can find the x bar and y bar value. Here we want to find out two unknown. So in your calculator, so we are going to press mode 3 times, we get equation 1. So press 1. Here we want to find out two unknowns. Unknowns 2, 3 we are having. So you have to press 2 and give the values of A1. A1 means first equation x bar quotient 7 equal to, next y bar quotient minus 16 equal to, and C means we are taking into the right hand side, that can be changed to minus 9. So that is minus 9 and A2 is minus 4, B2 is 5 and C2 is we are taking into right hand side, we get that value is equal to 3. So press equal to, we get x value is equal to minus 0.1034 and y bar is equal to, press equal to, we get y, that value equal to 0.5172. So these are x bar and y bar and this is the correlation quotient. In our question they are asking these three values. Next problem is in regression analysis. Find the two regression lines and the regression quotients for the given data. Fathers and sons they are given 65, 66, 67, 67, 68, 69, 70, 72. So this problem already we done in the previous class for a correlation. Same problem we are doing, but here they are asking regression lines and regression quotient. So from the previous problem I am taking the values R, we get R is equal to 0.603 which is known as correlation quotient, and x bar 68, y bar 69, sigma x equal to 2.1213 and sigma y equal to 2.3452. So I am taking from the correlation problem, same problem we done there. Okay, so using these values now I am finding the coefficients and the regression line. So first one is regression line y on x. Regression line y on x formula is y minus y bar equal to r into sigma y by sigma x into x minus x bar, right? So y minus y bar is, we know that 69, and r is equal to 0.603, sigma y equal to 2.3452, sigma x equal to 2.1213, and x minus x bar is 68. So we know all the values. So we are substituting here, and now we are simplifying. Y is equal to this minus 69 we are taking into other side, that can be changed to plus 69, plus we are simplifying this one. This is equal to 0.6664 into x minus 68, right? So this is also can be written as y equal to 69 plus 0.6664 into x, and plus into minus is minus, right? 45.3319. Okay. So this is 69 minus 45 point this one. Now we are simplifying this one, we get y equal to 0.6664x plus 23.6680. In y on x line, the x quotient is known as the regression quotient for y on x. So that regression quotient on y on x is, we are represented by byx. So that value is, we are writing this one 0.6664. Okay. So next we want to find out regression line x on y. Same as it is we are doing. X minus x bar equal to r into sigma x by sigma y into y minus y bar. Again, here r is known as correlation quotient, x bar is the mean of x values, y bar is the mean of y values, sigma x is the standard deviation, and sigma y is the standard deviation of y values. All values we are having here, we are substituting here, we get x minus 68 equal to r is 0.603, sigma x is 2.1213 by 2.3452 into y minus y bar is 69. Now we are simplifying this one, we get x equal to this minus 68 we are taking into right hand side, we are getting that is plus 68, plus we are simplifying this one, we get 0.603 into 2.1213 divided by 2.3452. So we get that value 0.5454 into y minus, plus into minus is minus, and this one is 0.5454 into 69. Now we are simplifying this one, x equal to 0.5454 into y, and into, we are simplifying these two values, we get plus 30.3652. Okay. So this is the x on y line. So in the x on y line, the y quotient is known as the regression quotient for x on y line. So that can be represented by bxy. The y quotient is 0.5454. So this is the regression quotient on x on y.